Hey guys, welcome back to my channel. In this video, I'm going to be going over trigonometric graphs. So, in GCSE maths, you need to know the sine graph, the cos graph, and the tan graph. So those are the graphs I'm showing you here on my screen. So the first graph we have here is y equals sine x, and there are a couple of key points you need to remember about these graphs. So for sine x, you need to know that the maximum y value is 1 and the minimum y value is minus 1. I also suggest you remember where these values occur. So the max, which is 1, occurs when x equals 90, and the minimum y value occurs when x equals 270. So that is a very important point on the graph that you need to remember. You also have x-intercepts every 180 degrees from 0 degrees. So you can see here, the graph crosses the x-axis at 0, 180, and 360. Again, you need to remember that the graph crosses the x-axis at these specific values, because a question could very well be draw the sine x graph, and in that case you would need to label the intercepts. And the graph will repeat every 360 degrees, so that would mean that this shape that you can see here, so it's like a wave-like shape between 0 and 360, that's the exact same shape that the graph will take between 360 and 720, so it repeats. And the next graph that we have here is y equals cos x. So this is essentially just a sine graph shifted 90 degrees to the left. So it also has the same maximum and minimum values of 1 and minus 1, except these values don't occur at 90 and 270. They instead occur at 0 and 180, because obviously it's a shifted graph. And it also has x-intercepts every 180 degrees, but this time it starts from 90 rather than 0. So as you can see here, you have a x-intercept at 90 and then 1 at 270. And this graph will also repeat every 360 degrees. This is the same for all the trig graphs except for the tan graph, which I'll go over now. And for the tan graph, there is no maximum y value or minimum y value. The graph will extend infinitely upwards and infinitely downwards. So essentially, you don't need to remember a maximum or minimum value, because just infinity and minus infinity. But what you do need to remember is the fact that it has asymptotes every 180 degrees starting at 90. So an asymptote is essentially a line. So you can see the dotted line that I've drawn here, that the tan x graph will never cross. So it will get infinitely close to the line that is x equals 90 and x equals 270, but it will never ever touch that line. So what that means is that there is no defined value for tan 90 or tan 270. These are undefined. It also has x-intercepts every 180 degrees starting from 0, as you can see on the graph here. And for the tan graph, it repeats every 180. So the shape you see between 90 and 270, that will repeat itself every 180 degrees. But obviously, if you want to sort of just make it so it's the same for all three, you can consider the shape between 0 and 360, and that will repeat every 360 degrees as well. Now, all of these graphs extend infinitely on the positive and negative x-axis. So that means it will infinitely extend into the negative x. So between minus 360 and 0, you will have the same shape of all these graphs. And from minus 720 to minus 360, again, the same shape. Same for the positive x-axis. So these just extend infinitely across the x-axis. Now, symmetry of graphs is something that's very useful when you're doing trig questions, because often what they'll do is they'll give you a value of y, and then they ask you to find the x value using the trig functions. And for that one y value, you can often have multiple values of x, and so you don't want to lose out on any marks by not getting all the solutions that they're looking for. So starting with sine x, so it has these lines of symmetry. So between 0 and 180, you have a line of symmetry at x equals 90. So essentially, the part from 0 to 90 is just reflected over to give the part between 90 and 180. The same is the case for between 180 and 360, it's just in the negative quadrant rather than the positive quadrant. So what this gives us is sine x equals sine 180 minus x. Now, this is an equation you don't have to remember if you know the symmetry of the graph, but I suggest that if it helps, you should definitely remember it, as it will help you get the solutions that you're looking for without having to necessarily draw the graph. But I think the best practice in all your GCSE maths papers would be to just do a simple sketch of the graph, as long as you know where the intercepts are, and you can roughly mark on the y value that you're looking for. And for the cos graph, because it's just the sine graph shifted, we have this sort of U kind of shape. So we just have a singular line of symmetry at x equals 180, and that pretty much just makes it just so easy to calculate any values that you have. So if there's a value of y that they give you, say like 0.5, you know that that same value is going to be the same distance away from 360 as it is from 0, which will make more sense when I show you the question later on. So this gives us the equation cos x equals cos 360 minus x. So you just take away whatever the x value that you get from 360 to get that value, which will give you the value of y that you have. Now I know this sounds a bit complicated right now, but when I give an example, it will make sense. In terms of the tan graph, because it repeats every 180 degrees, all you do is you do x plus 180. So if you have the x value, say 45, then you just add 180 to get the next one for the same y value. So a question you could possibly get is for something like this. This is a very easy question. And so what you want to do is you want to look for where x is 90. So that's that point. And because you know from your knowledge of the graph that it is 1, because the peak of the sine graph is at 90. So here's a kind of question that you're more likely to get. If sine x equals 0.5 for 0 for x between 0 and 360, you want to find x. So if you have a graph here, as you can see, there are two values of x that will give you 0.5. Now, if you think about this first point that we have here on, on the graph, that has a certain distance between itself and 0. And if we consider that distance to be, say, z, then the second point that we have here is also distance z away from 180. So that's how we have the sine x equals sine 180 minus x. And that simply works for the cos graph as well. So that's how we get 45 or 135. Now, obviously, you're not meant to know these off by heart. This is something you're going to use a calculator for. But I'm just trying to show you how if you do this without a graph, you just get 45 degrees, because the calculator will give you the first value that it gets when calculating the inverse sine of 0.5. But as you can see on the graph, you actually have two solutions between 0 and 360, and you don't want to miss out on the second solution. And you get that solution by just doing 180 minus 45. So thanks for watching. I hope this helps, and good luck for your GCSEs. Make sure you subscribe so you don't miss out on any of my videos. If you want me to go over any specific topics, do comment down below and I'll be happy to record them.